Right, last question. We have a figure 2 shows a sketch of the curve, this, y equals f of x, where x belongs to a set of real numbers, where f of x is 2x take away 5 all squared times x plus 3. Okay, so the curve with equation f of x minus k passes through the origin. Find out the value of the constant k. So there's not a lot to be done here actually. It looks like there might be, but not really. So what it's saying is, if you take away some value from here, you get to here. That's all it's saying. So all we've really got to do is find the y-intercept, and we found k. Alright, and I could expand this whole thing out, but I'm not going to. Hopefully you can see that the number you get at the end is going to be negative 5 all squared multiplied by this 3 here. Yeah. Because just remember that this is the same as this. So the only way to make that true is to do negative 5 times negative 5 times 3. Well, that gives us 75. Yeah, so let's do it down here. So a part I, so the y-intercept is 75, so therefore k is 75. And that'll do. That's quite clear enough. Yeah. Similarly, let's have a look at part 2. The curve with equation y equals f of x plus c has a minimum point at the origin. Well, here's the minimum point, and it needs to move left, which should make sense. Remember, if it's in the brackets, it does kind of opposite of what you'd expect. So this goes left. So you need to figure out how much this goes left by. It's very easy to just quickly jump in here and look at this bit. This is obviously the representation of this minimum point here. I mean, the whole thing is, but we care more about this point, the double root. That's why it just comes in, just touches and turns back up. This is dx plus 3. So all you've got to do really is look at this bit all squared, and you want to think, how do you turn that back into a 0? And I mean, all you've got to do is substitute a number in for x to get that. And it has to be 2.5, yeah, because 2 times 2.5 is 5, take away 5 will be 0. So all I'm going to write down here is that c is 2.5, I'll put it as a fraction, so 5 over 2, okay, and that's it. So that's part 1 and 2 done. Yeah, that was just mucking around with graphical transformations. If you can see them, that's nice. If not, it's a bit tricky, but there we go. So B, we've got show that f dashed of x is 12x squared, take away 16x minus 35. Now at this point, probably I'm going to have to expand this. Those of you doing C4, C3 or whatever it is as well, you could probably use the chain rule and all that stuff, but yeah, I'm not going to do that. So let's expand this out. I'm going to choose the 2 hardest ones first, and then multiply by the 3rd one. So let's start writing them down. Yeah. So expanding this out, you get 4x squared minus 10x, which is minus 20x, plus 25. I'm now going to times all of that by x plus 3. We get 4x cubed minus 20x squared plus 25x. That's just 25x. Just multiplying that all through by x. Now multiplying it all through by 3. I'm just going to line it up nicely underneath. Yeah, we've done this before. Yeah, and look at that. You can see that 75 popping out there, which we expected. So we get 4x cubed minus 8x squared minus 35x plus 75. Okay, so there's our f of x. Let me just switch to some more paper. Ooh, there's my ruler gun. So f of x is 4x cubed minus 8x squared minus 35x plus that 75 there. Differentiation, remember, you multiply by the power, subtract 1 from the power. So f dashed of x, 3 times 4 is 12, and then 3 take away 1 is 2. 2 times 8 is 16, and then 2 take away 1 is 1. Don't need the 1 there, I'm just for completeness. This just reduces down to a constant, minus 35. Think of it as timesing by 1, taking 1 off, comes to an x to the power of 0, but I think the power of 0 is just 1. And then this vanishes, which is exactly what we're asked to show. So there we go, we're done with that bit. So let's read C, let's bring that back in. So the points A and B are distinct points that lie on the curve y equals f of x. The gradient of the curve at A is equal to the gradient of the curve at B. Given that point A has x coordinate 3, find the x coordinate of B. Okay, a bit of a mouthful there, but all I'm going to do to start with is I'm just going to take this fact and I'm going to go with it. The gradient of the curve at A, and then it gives you the x coordinate of 3. Okay, so before anything else, so at x equals 3, let's just find the gradient. So let's do f dashed of 3. This is going to give us the gradient. So we've got 12 times 3 squared, take away 16 lots of 3, minus 35. 12 times 9 is 188. Ooh, minus 48, it's been a long night. Minus 35. So this is 60 take away 35, which is 25. Okay, so there's the gradient. So at A we have a gradient of 25. Coming back to the question now, it says this is equal to the gradient of the curve at B. Okay, so I'm going to let the f dashed of x equal 25. Okay, because the gradients are the same, and we know the gradient in A is 25. So now I've got 12x squared take away 16x minus 35 equals 25. So I'm actually now going to solve another quadratic. So I'm going to make it equal to 0 and just give myself 12x squared minus 16x minus 60. I can probably make that a little bit easier. 30, yeah, divisible by 4. So let's go over here. Ooh, so 3x squared minus 4x minus 15 equals 0. I can't reduce that anymore, so we'll just work with this. Is this factorizable? Yes, I'm going to say so. I can spot that, so definitely factorizable. If not, you can use your quadratic formula, but this one's actually quite nice. You can do this quite nicely. All right. Ooh. So we have 3x and x equals 0. So we've got a negative 15. So we probably want a negative 3 there to get us negative 9x. And plus 5 there, plus 5x gets us back to negative 4x. Remember, we've got methods to actually do this much nicer. This is just me factorising it. If you want to do the whole 3 times negative 15 and then finding out the factor pairs, you can do that. I'm just going to go straight ahead and do it. So firstly, I'm going to look at this. We should expect this. We get x equals 3. We knew this, we kind of were expecting this, so we know we're on the right lines. We found this was true already earlier at the start of this question, so we know we're on the right lines. So this isn't what we're looking for, this must be what we're looking for here. Alright, so therefore we've got 3x plus 5 equals 0, which leads to x equals minus 5 over 3. Okay, that concludes C1. Do let me know if there's anything in there that was unclear, but yeah, good luck.